Welcome back to our online lesson. So today's lesson will help you tackle exercise 4b from your methods textbook. Now the topic is evaluating a definite integral. Now to evaluate a definite integral, we're going to use the fundamental theorem of calculus. Now what is a fundamental theorem of calculus? It's written in the bubble here. Its integral of any function from a to b is fb take fa. So a and b are called the limits of the function. A is the lower limit and b is called the upper limit, and capital F is the antiderivative of small fx. So to find the definite integral of any function, you need to follow these three simple steps. Step number 1, you find the antiderivative of fx. Then step number 2, you substitute the upper limit in capital Fx, that is in the antiderivative. And then third step, you substitute the lower limit in capital Fx. And then what you do, you subtract fb take fa, means step 2 subtract step 3. Let's make it clear by taking one example. So question example 1 is you want to antiderivative of 3x squared plus 4x from 1 to 2. So this is a definite integral from 1 to 2. 1 is the lower limit and 2 is the upper limit. So first step we're going to do is find the antiderivative of 3x squared plus 4x, which is x cubed plus 2x squared. And then when you antiderivative for the first time, you put a square bracket and the limits on the right hand side of the square bracket. And then you substitute one by one in the square bracket. So what you do, you replace x by 2 inside the square bracket, and then you replace x by 1 inside the square bracket. And then evaluate, do some simple BIMDAS, adding, subtracting. So the first bracket will work out to be 16, and the second bracket will be 3. 16 take 3, the final answer is 13. Now let's have a look at another example. Say you want to anti-differentiate square root of x from 4 to 9. So diagrammatically this is represented on the right. So it's like finding the area of the curve y equals square root x between 4 and 9. So the shaded part will be the area. We're going to look at that in our next lesson. How to find area under a curve. You have to anti-differentiate between two limits. And coming back to this question, how to anti-differentiate root of x 4 to 9, you just have to do 3 steps. So first step, you anti-differentiate square root of x, which is x to the half. Anti-differentiate means you add 1 to the power, divide by new power. So adding half, 1 to half give you 3 over 2, and dividing by 3 over 2 give you 2/3. Again, you put a square bracket, 4 and 9, and then you sub 9 and 4 and then subtract. That will give you the final answer. So how do you evaluate 9 to the power of 3 over 2? That means square root of 9 to the cube. Square root of 9 is 3. 3 to the cube, that will give you 27 later on. And same for 4 to the power of 3 over 2. That's square root of 4 to the cube. Square root of 4 is 2. 2 to the cube is 8. So when you simplify these, you'll get 18. Take 16 on 3, which works out to be 38 on 3. Now, if you're allowed to do the question on a ClassPad calculator, you follow these 4 simple steps. So how do you evaluate a definite integral on your ClassPad calculator? You go on the main, you press keyboard, maths 2. Then on the third row, fourth column, you'll see this symbol, which is 2 little rectangles where you put your limits, and the black rectangle where you write the actual function, like 3x squared plus 4x, and then the answer will come up in one simple step. So hope you enjoyed the lesson, and you should now be able to do exercise 4b. Thank you.